In this video, I am going to talk about the BGP cast community. BGP cast community is one of the BGP extended communities that we can use this community when we are using EIGRP between the P and C. You know that in previous video we talked about the BGP extended communities that we can use them for advertising the BGP attributes with extended community of the BGP. Let me to talk about the need to cast community, and after that we can configure the scenario. Look at this scenario. In this scenario, we have a service provider. This is the service provider, and in service provider we have two edge router, router 1 and router 4. These two routers are PE routers. And also we have two P routers or core routers. Look at here, R1 is the PE router, for example, PE1, and then the router 4 is PE4. Okay, and also we have two P routers, two core routers. The first is P2, means the P router 2, and then P3. Okay, this is the service provider. In this service provider, we are using OSPF as the IGP. You learn about the configuration of the OSPF in this scenario in the service provider environment. And also we have BGP with the AS number of 65,000. Okay, and we have BGP neighborship between the router 1 and router 4. Let me to show you here. We have one iBGP neighborship between these two routers. Okay, router 1 and router 4. As you learned, we can configure BGP neighborship between the router P routers, and after that we can use this neighborship for advertising the VPN v4 routes in the MPLS layer 3 VPN. This is the VPN v4 routes, okay, between the router 1 and router 4. And also we have a customer. This is the customer. As you can see, our customer has two sites. The site 1, for example, this is customer A, site 1, and also this is the customer A site 2. This means that our customer has two sites, the site 1 and also site 2, and here we have only one customer. But as you can see, we have a direct link between two customers. You know that in most cases we don't have a direct link between the customers. For example, this is the normal usage of the MPLS layer 3 VPN. We have only one connection between two sites of a customer, and that is the MPLS layer 3 VPN link. Okay, but in some cases maybe we use another link directly between two customers, and we call it backdoor links. Backdoor links in most cases should be used when only the MPLS layer 3 VPN link, for example, failed. If the MPLS layer 3 link failed, we can use the backdoor link. Because of that, the backdoor, for example, bandwidth or the backdoor specification is, for example, has a lower performance than the main link from the MPLS layer 3 VPN. For example, the bandwidth is less than the MPLS bandwidth, and the, for example, delay maybe is more than the delay of the MPLS link. And because of that, we need to use the backdoor link as the secondary link, as the backup link, not the primary. Okay, if the configuration, okay, occurs correctly at the final step, we need to use the MPLS layer 3 link as the MPLS layer 3 link as the primary link. Okay, MPLS link, and as the secondary link we can use the backdoor link. This is the desired scenario and desired function that we need to reach to this, for example, condition. Okay, let me to talk about this scenario, and you should know that the cast community or the feature that I am going to talk about that only occur when you have one backdoor link. If you don't have backdoor link, we don't have any problem. But if you have backdoor link, we need some features, and maybe we encounter with some problem. Let me to talk about this. Here is the, for example, a net address. I use 192.168.60/24 here, and you can call it net A. Assume that this is the net A. I'm going to talk about one of the networks, for example, Net A. You can use these networks or Net A, it's not important, but let me to talk about the Net A. You know that we configured EIGRP between router 4 and router 6 as the PEC routing protocol, and also we configured EIGRP between router 1 and router 5 as the IGP routing protocol. And because we have direct link between the R5 and R6, this is the backdoor link. In most cases, we are using the same routing protocol here, for example, EIGRP. This is our scenario. You know that the Net A, okay, should be advertised to the for example, PE from the R6, the C. Look at here, R6 is our C router, and we need to advertise the Net A to the R4 because we have EIGRP here, and after that, R4 can learn this update from the EIGRP. You know that in the router 4, we are using redistribution from the EIGRP to BGP. And after configuring the redistribution from the EIGRP to BGP and also from BGP to EIGRP, first EIGRP routes should be injected into the BGP, and BGP should convert this update to the VPN v4, and after that it should advertise to the neighbor. For example, the Net A now can be advertised to the router 1 because we have neighborship BGP, IBGP neighborship between the router 4 and router 1. And after converting this update to the VPN v4, for example, with the 65,000:1:, and this is the VPN v4, okay? This update with some attributes, for example, RT, or some other attributes, as you learn 0x8800, 0x8801, 02, 03, 04, 5, and 6 can be sent to the, for example, router 1. When this update received in the router 1 should accept this update and import the update into the, for example, the VRF with the same route target import, you know it. And because of that, the actual route, not the VPN v4, should be injected into the routing table of the VRFA. This is the normal condition, and you learn about the configuration of this feature in the previous videos. Also, you know that the Net A should be advertised from the, for example, router 6 to the router 5, because here we have EIGRP neighborship. Let me to show you. This is Net A 192.168.60/24, and this should be advertised to the router 5. And when router 5 learning this update, it should send the update to the R1. Here, R1 now is learning the one update 192.168.60/24 from two paths. Okay, the first pass received from the, for example, router 4, and the next pass is received from the router 5. Here we have two conditions. Let me to talk about the two conditions. The first condition, okay, is that first, we are receiving the MPBGP update, means we are receiving first VPN v4, and then the EIGRP routes received from the router 5. Look at here, this is the EIGRP route received from the router 5, and this is the MPBGP update. In this situation, we don't have any problem. Why? Because you know that R4 should advertise this update to the R1, okay, and also from the BGP, and also from here the R1 should learn it. And you know that from the R4, the metric of the R4 to these networks should be sent into the, for example, R1 with the attribute of the MET. Okay, in MET attribute, you will see the metric from R4 to this network. Let me to calculate the metric from here. You know that for calculation of the metric of EIGRP, we need to use this formula, 256 multiply 10, okay, to power of 7, and then over the minimum bandwidth. This is the bandwidth of this link. The minimum bandwidth of this link, because this is fast Ethernet, is 100,000 kilobit per second. And then we have here a delay value. Okay, the delay of the fast Ethernet is